Height versus depth in trees. This lecture is mainly for two purposes. The first thing is we want to clarify on what exactly is height, what exactly is depth, and what are the differences between these two concepts. See, these are very similar concepts, so we just want to highlight on what exactly are the differences between height and depth. And the second thing is we'll go through few calculations which are related to height and depth. So what these calculations, these formulas will do is it will provide more clarity to your understanding of trees and also about the understanding of height as well as depth of a tree. So let's start with this. We'll start with what exactly is height, what exactly is depth. So what is height of a tree? Height of a tree, it is defined as the length of the longest path from the root to any of the leaves in the tree. So how do you see this? If this is a tree, from the root, how do you calculate the length of the longest path to the leaf? So first question is, how is length calculated? Length is calculated in terms of number of edges. So if you're going to this leaf node, then number of edges to be crossed in order to reach from the root. That is the length. So if this is your root, then from the root 1, 2. So 2 edges are to be crossed in order to reach this node. Similarly, let us say there are 2 more nodes here. These 2 nodes are also there. Then in this case, how do you calculate height of this tree? So you will see each of the leaf nodes and you will try to see the distance of that leaf node from the root. So if you see for this leaf node, you know the distance is 1, 2, 3, which means height of the tree is 3 because you take all the leaf nodes and you calculate height separately and you want to see the maximum of all those, that is the height of the tree. So if you take this node, then the distance from root is 1, 2. So 2. If you take this node, distance from root is 3. If you take this node, it is 3. If you take this node, it is 2. This node, it is 2. So whichever is the longest, that is what you consider as height. So height of this tree is 3. What is depth? What is the concept of depth? Depth of, let us say, we're taking this node. So depth is the level of this node in the tree. And how do you measure this level? This level of this node is also measured as number of edges from the root. So if you take this particular node, how do you calculate number of edges? You have 1 is this edge, 2 is this edge. So the depth of this node is 2. So at this point, you may feel like height is also calculated using the same logic. Depth is also calculated using the same logic. So both are one and the same. But the catch is that the only similarity between height and depth is that for calculation of both, you use the same criteria called number of edges. Both are measured in terms of number of edges. So that is the similarity. Difference is that height is the property of a tree while depth is the property of a node. This is the main difference between height and depth. How do you see height of a tree? You either see height of a tree or that of a subtree. You don't generally say height of a node. So if you take this tree, height of the tree is 3. What if I take this subtree? Height of this subtree is 2 because for this subtree, this is the root node. And from this root node, if you check distances to all the leaves, maximum value is 2. So for this particular subtree, the height is 2. So you generally you talk either about the tree or about the subtree while talking about height. And what about depth? Depth is always the property of a node. So you talk about the depth of nodes. That is, it need not even be leaf node. You can take any node. This node also has depth. This is at a depth of 1 because the distance from root is 1. What about this node? It has depth of 2. This node, it has depth of 1. So depth is the property of a node and height is the property of tree or of a subtree. Still, there may be cases when people may say, okay, height of this particular node. So still you have to understand height and depth. The difference is one you measure as a top down measurement, and the other is a bottom up measurement. How is it? Because if you take this root node, and let us say you want to see height also as a property of node. Still, what will be the height of this? Height of this will be 3. But what is the depth of this? Depth is 0, because depth is counted always from top. But height increases as it, when for the root node, height will be maximum, but depth will be minimum. But in general, always keep in mind, height is always for a tree and depth is for a node. So you either talk about tree or subtree when you're talking about height, and whenever you're talking about depth, you are generally talking about a node. So it need not be leaf node, it can be any of the node. Every node is at some depth. Okay. Next thing is, we'll get into calculations related to height and depth of nodes. So this will also give you some idea about trees. That is why I want to do this. So the first thing is, what is the maximum number of nodes that you can have at any depth d? What is the maximum number of nodes? We are only considering binary trees. So let me be clear on this. We are only considering binary trees here. So for binary trees, what is the maximum number of nodes you can have at a particular depth d? This is the question. So how can you form a formula for this? If you have any tree like this, simply by observing itself, you will be able to give an answer here. So when your depth is 0, this is depth 0, you have maximum 1 node. When you are at depth 1, you have maximum 2 nodes. When you are at depth 2, you have maximum 4 nodes. So what is this telling you? This is telling you that at any depth d, you can have maximum 2 power d nodes. This is what it is. The observation is telling you. So when you have any tree, so I'm only talking about maximum number of nodes. So it is possible that maybe your tree doesn't have these children. That in this particular level, which is level 2, you have only 2 nodes. What I'm saying is maximum is 4 nodes. 2 power d is the maximum number of nodes you can have at any depth. Okay. So this is the first thing that I want to tell you. Second thing, what is the height of a tree if the tree is having n nodes? I'm telling you, this tree is having n nodes. If it is having n nodes, what is the height of this tree? If this is the tree, it is having n nodes, what is the height? Height can be derived as floor of log n if n is the number of nodes. So let us just check with. So whenever I say log, keep in mind it is log to the base 2. Okay. So if I'm taking till this point, totally there are 3 nodes. If this is my tree, then there are 3 nodes. What is log 3? And see, we want the integer. That is why we are doing this. Okay. So log 3, log 3 is 1, which means height is 1. So it is not log 3, floor of log 3. So the integer that is lower than that. If you have one more node, what happens? Then you have 4 nodes. Now log 4, what is floor of log 4? It is 2. So how did I get 2? Because 4 can be written as 2 power 2. So log 2 power 2 to the base 2. The log is always of base 2. So this will be 2. So from 4 till 7, you are going to get answer as 2. And the point it becomes 8, log 8 will be 3. So till 7 means 1, 2, 3, 4. When 4 are here, this is when you have total of 7 nodes in the tree. And at this point, using this formula, you will understand height is 2. Okay. So in order to calculate the maximum number of nodes at depth d, you use the formula 2 power d. And what about the height of a tree which is having n nodes? Then you use floor of log n. Next thing is, if I'm telling you that a tree is having some particular height h, and you want to find maximum number of nodes in this complete tree. So previously what did we do? We found maximum number of nodes at any particular depth d. This time I am telling you that the height of the tree is h. I want you to tell me what is the maximum number of nodes possible in a tree of height h. So we are going to use the formula that we already learned, that is maximum number of nodes at any particular depth d is 2 power d. We already learned this. So we are going to use this formula in order to find maximum number of nodes in the tree of height h, because we'll take each level and we'll add those up. So if this is the tree, then at first level, what is the maximum number of nodes possible? It is 2 power 0 because it is level 0. So as per the formula that we already learned, 2 power 0 is the maximum number of nodes possible at level 0. So 2 power 0 is 1. Plus at level 1, what is the maximum number possible? It is 2 power 1, 2 nodes. And what about level 2? 2 power 2. So like this, it will go 2 power 3 plus 2 power 4 plus this will go on like this till what point? 2 power h. So considering h as the height, we have total of these number of nodes. This is the maximum number of nodes possible if the height is h. And this total can be written as 2 power h plus 1 minus 1. So which means maximum number of nodes when you have a tree of height h is 2 power h plus 1 minus 1. And the next thing is, what is the maximum number of leaf nodes? So how can you find maximum number of leaf nodes? If the height is h, you want to see what is the maximum number of nodes possible at depth h, which is 2 power h. So maximum number of leaf nodes in height h is 2 power h. So what all have we learned till this point? Let me just summarize. First thing is maximum number of nodes at depth d is 2 power d. Second thing is height of a tree. When you have n nodes, it is floor of log n. Next thing is, for a given height h, what is the maximum number of nodes in a tree? So that is 2 power h plus 1 minus 1. And what about the maximum number of leaf nodes in a tree? It is 2 power h, given h is the height of the tree. So these are the calculations that I wanted to clarify. And the next thing is, if you are talking about complete tree and you are considering depth and height both as property of tree only, in that case depth is equal to height. If you are saying depth of a tree and height of a tree and you are considering both as properties of a tree, then the values of depth and height will be same. Okay, so this is it about height and depth of a tree.